Okay, so now let's start wiring all the cabling into the box. In the last video we made up all of our cables for our X and Z steppers, our on-off switch, our tack, the home switches, our control cable for the potentiometer, as well as our e-stop, and our spindle motor. So now we need to get these connections made inside the box. And over here to the left is our spindle cannon plug. We're going to bring it into the box and we're going to make our connections to our VFD. Let's start with the ground. And you can see that I tin the ends of the wires just to keep them from fraying. And there's a terminal labeled PE. This wire is going to go connect into there. We'll just tuck this wire down into the box like so. And there is our ground wire. Our next wire is T3, and T3 is our red wire. And remember, I didn't have red, so I put some red heat shrink on there, and I will do the same at this end. Red tape, it's just something to identify it, so you can keep them separate. Okay, and that is going to go on T3. Okay, and T3 is connected. And tuck it down here out of the way. Now we have T3 connected. And then we have T2, which is our white wire. T2 connected. Now T2 is connected. And the last wire is T1. Our last wire is T1, and now that is all the connections for the power going out to the motor for the VFD. We tuck the wires in nice and neat down in the bottom of the box. And this right here, where it says DC, this is a positive and negative connection for a braking unit. The manual is not very clear. It's pretty vague about the braking module, It appears that you need a braking module and a braking resistor. I'm not real sure. Right now I'm not going to be too concerned about it. In the future I may try to add it if I feel like I need it, but right now I don't think I'll need it, so we'll see. Okay, so next we're going to add our aviation plugs for our on-off switch, our tack, and our home switches, and our e-stop. And then I'll just repeat this for the following aviation plugs. So all of our cabling is in the box. The last thing we need to do is put in our breakout board and then make all these connections. So now, since we have our aviation plugs mounted in the box, now it's just a matter of connecting our wiring to our devices. The first connections we're going to be making are to the VFD. This is our control wiring for our potentiometer, forward, reverse, e-stop. Okay, so our first connection is going to be our 24 volts, and it is wire number, our red wire, and pin number 3. One nice thing about using this solid core wire is it goes in these very easily, and makes for a good connection. Definitely make sure you get it in the right number. Our second wire is our forward, and that is our black wire, and that is going to be pin number 4. Our next wire is our reverse, and that will be our brown wire. Moving right along, our next wire is our base block wire. Base block wire S3, and that's going to our emergency stop. and it is going on terminal 6. That is S3. S3 is our orange wire. Then our next wire is our E-stop, which is S4, and it's going to terminal 7. S4 is our light blue wire. And that goes to terminal 7. Our next wire is for our potentiometer, 10 volts, and that will go on terminal 9. And our 10 volts is our purple wire. And we're going to skip terminal 8 and we're going to go to terminal 9. That's in. Our next wire is our AIN, analog input, and that'll be our 0 to 10 volts from our potentiometer, and that's going on terminal 10. Our AIN is our blue wire. And our last wire is our common. It's going on terminal 11. And that is our green wire. So there we have our finished terminal wiring to our VFD. On the back of the cover for our VFD, it gives you the terminals and the description of each terminal. Also, see if you can see, right here we have 2 dip switches. Switch 1 is for voltage or amperage, and that pertains to the potentiometer. In our case, we are going to be looking for a voltage. So we will set it to V, and that is up. And then the second one is either positive, negative, positive, or negative, positive, negative. And that relates to our forward, reverse, and E-stop. These 4 inputs here. We will be using positive because we're going to be using 24 volts and it's going to be looking for a positive. So we've got ours set up for positive, negative, positive, which is down, and that's pretty much it for the VFD. All we have to do now is just program it once we get it powered up, and we'll go through that later. So now let's move on to the next set of cabling, Alright, so let's continue with our wiring. The first thing I want to wire up, get this out of the way. First thing I want to wire up is our 5, 12, and 24 volt power supply. I want to bring in my common. And we're going to put it right here on the terminal board. And as you can see, I just jumpered it over. So we're going to use these two center terminals for our ground, or common, these two for our 5, and these two for our 12 volts. Bring in our 5 volt here. And our 12 volt. Make sure that one's tight anyways. Okay, so there we have power to our terminal board 2 from our 5, 12, and 24 volts. I hooked up the cooling fan to our common and our 12 volts. And next, we want to connect our cabling coming in for our e-stop, our on-off switch. So we'll be connecting this wire from 1L1, this wire, and this wire coming back to L, which is actually terminal 43, and also terminal 44, which is our power wire. So let's get those connected. So the first wire we're going to connect is our white wire, which is 1L1. And you can see how much nicer it makes it if you just leave it all in one cable. It's easier to see where the wires go. To me it is. And I think it just works out better. So 1L1 is this terminal down here. Where the black wire is connected. And then we have our black wire, which is 43. In our case, it's a blue wire here. Goes to terminal 43. This has the jumper down to our coil A2, and excuse me, A1. So we're going from 3 right here, and we're going down to A1, our coil. That's this red jumper wire right here. Next, we want to go with 44, which is our red wire. And 44 is right here. And last is just a common wire that we need to attach. Okay, so we wired up the final wire after I spliced on an extra piece here. And this is our common. And so we have our on-off switch connected. And next will be our tachometer. And this yellow wire will go to our breakout board. And we just need to supply power. Our tachometer runs on 8 to 24 volts. So we're going to connect this to our 12 volts. Our red will be our positive. I always like to give a tug to these connections when they get done, because you can see they might just pull out, especially when you're dealing with these real small wires. Alright. All we have left now would be our stepper motors and our home switches. So the next thing we're going to wire up is our stepper motor drivers. This one right here is a DM542A from Long's Motors. This one here is a DQ542MA, and this is from Wanty Motors. And as you see, they're identical stepper motor drivers. The only difference being just the name printed on the cover. I think a lot of people get confused wiring these up, so I just want to kind of go through it. Take a minute and kind of go through it. So over here you have some dip switches, 1 through 8, and this is for your pulse as well as your current. Now we are using 3 amp stepper motors, so the peak is 4.2 and the RMS is 3. So we're going to be setting ours to switch 1, 2, and 3 to off, off, off. So 1, 2, and 3 will be off. That is over to the right. Switch 4 is half current or full current in a hold state when the motor's not moving either direction, it's just holding. And so I like to set mine to half current. So switch 4 will also be off. And then 5, 6, 7, and 8 is for your steps. We're going to be setting ours up to 400, which will be off, on, on. So the last 3 will be on. So we just set our dip switches like so, and that's all there is to it. Now you can see here, here's your power coming in. This is your DC ground. In our case, it's 36 volts. This particular driver will is 0 to 50 volts, I believe. Excuse me, 18 to 50 volts right here. And we're going to be using a 36 volt power supply. So this is our DC negative and our DC positive, and this is power going out to the motors. Enable 5 volts, and enable we will not be using. And we will be using our direction and our 5 volts positive and our pulse and our 5 volt positive. Now one thing about these is these plugs pull out, so it makes it for wiring a little bit easier, especially if you've already got it mounted in the box. So we'll do that now. So the first thing I want to do is bring power over to our stepper drivers. So our ground, or negative, is going to be our white wire. I've already ran these wires over to the power supply. And that is our first terminal. And we are also going to jumper over to our second stepper. So I'm going to put 2 wires in here, like so. Give it a good tug. That is our ground. This is our ground terminal. And then we have our 36-volt positive, which will go right beside it. Okay, get those in, get them good and tight, give it a nice tug. And that is our power and our ground coming in. The next wires will be our outputs going to the motors. Our A+, A-, B+, and B-. So we'll do the A+ first. Our A+ is our black wire. And this is our Z stepper. So we get our plug for our Z stepper. And you can see I left these a little long. But this, our A+ is our black wire. And that goes in this first terminal. A+. Our next wire is our A-, which is our green wire. Our next wire so that's our A+, our A-. Our next wire is our B+. For our B+, we are going to be using a red wire. Our B+, and our last wire is our B-, which will be our blue wire. Remember, we had a couple extra wires, so I'm just going to fold those back like so. get a piece of heat shrink and just kind of, excuse me, a piece of electrical tape. Okay, so that is power going out to our motor for our Z-axis, and we just need to repeat the wiring for our X-axis. The next thing we want to do is we want to bring our 5 volts for our signal over to our stepper motor drivers. Depending on which breakout board you have, there's a couple different ways you can do it. This is a Long's Motors or a Wanty motor breakout board. This is just a standard DB25 board. If you're using one of these boards, then you want to bring the 5 volts that you bring, the 5 volts you bring into your breakout board, you just want to jumper it over to your stepper motor drivers. I will be using a CNC4PC. This is a C10 board. This is a C10 board, and it has the 5 volts on the board. So I'll be running it straight from the C10 board. Now we'll mount this board in the box after I get it wired up. Just makes it easier. The first thing I want to do is I want to bring in my 5 volt power. And to do that, we're going to run a wire from our terminal board 2. So we need a common wire. Common wire coming from our 5 volt power supply, and that needs to come up to our breakout board. We'll put it in so I can see about where we need to go. Alright. And we're also going to need a 5 volt wire. It's nice to use different colored wires and try to stay the same through the whole process. It just makes it easier to identify things in the box. And now we just need to bring our 5 volts over, which will be our blue wire. This C10 board needs 5 volts here, but it also needs 5 volts for this enable. So I'm just going to jumper it over like so. To provide both 5 volts for the enable circuit as well as the 5 volts to the board. Okay, got our 5 volts in. Tighten those up. And bring our ground in. That's good. I'm going to just temporarily mount this because I like to be able to keep pulling it out to connect my wiring. Makes it a little easier. Okay, so we have our power going to our board. Okay, so now we have our power going to our C10 board and our common, and now we just need to bring that 5 volts over to our stepper motor driver, and that will be coming out between pin 4 and 5 because we're going to use 4 and 5 for our Z-axis. So right here you have pins 4 and 5, and where it says common here is actually our 5 volts out because we have our jumper set on 5 volts. So you can unplug these, and I want you to see, make sure that you have your actual terminal open. As you can see, it looks open, but it's actually all the way closed. So open up your terminals. And then this one, this terminal here is your enable, 5 volts and enable. We're not even using that. So if you want, you can just unplug that so you don't get confused. So where we're going to plug in is our 5 volts positive for our pulse, and we're going to jumper it over to our 5 volts for our direction. So I've got a little jumper wire here. I'm going to just put that in and get that terminal screwed in. Like so. Put that there for now. Then we're going to want to bring our 5 volts between terminals 4 and 5. It says common, but it's actually 5 volts. So we're going to put that wire in there. And that's going to supply 5 volts to our Z-axis. Like so. Get that tightened down. Okay. So get plugged in like so. 5 volts going to our pulse and 5 volts going to our direction. Then our next wire for our Z-axis will be our step negative and direction negative. And the step negative will be on, excuse me, we're doing the Z. Our step negative will be on the pin 4 and our direction negative will be on pin 5. So our next pin is our pulse or step, and that is this pin, and that's our step or pulse negative. And we will use our red wire for our step. negative. That will be pin 4. Goes into there. Like so. Our pulse negative, and then we need to do our direction negative, and we'll use a green wire. And that goes in pin 5. And that goes in our last pin. And there you go. So you can see we have our dip switches set. We have our pulse and direction going to our breakout board wired up, and we also wired up our power. So the mystery of the stepper motors is solved. There we go. And then we'll just do the same for our X, and we'll use pins 2 and 3 and the common in between. So let's get those wired up. Okay, so you can see we finished up the wiring of our stepper motors drivers. We have our Xaxis complete, and also I added the Xaxis. Now I use different color wires because I just think that, I mean, it's not a big deal, you can use the same color, but it's just easier for me to follow the wires and see where they're going. And it just kind of helps to have the different colors. You can see we still have a lot more outputs here that we're not going to be using because this is a lathe, and right now I only have 2 axes to worry about. The next wire I'm going to add is the tach signal wire. We wired in the power for the tach earlier, and now since I have the breakout board in, I'm going to add this tach signal, which is the yellow wire, and it's going to be an input on pin 15. So we have our yellow wire here, and we're going to just attach this to pin 15 on our breakout board. It's that simple. And then next we're going to start wiring up our home switches. We've got a black and a red wire. You can run these in series, and that's fine if you want to conserve some of your inputs, but since this is a lathe, I'm not going to be using all of these inputs, so I just separated them. So for the Z-axis, I'm going to be using pin 13 and the 5 volts. So we find our Z-axis. And that's this top one. And we're going to run it over. And we will attach the black wire to the 5 volts, which is right here. I like this board because it gives you separate power for each individual input. And pin 13 will be our input, which is our red wire. Yeah, this board's nice because for each individual output and input it gives you a 5 volt, whereas on these you get from Long's Motors, these just standard DB25 boards, you only have the supply power, and all the inputs only have they're supplying 5 volts at each pin, and then you just have the ground. So it's nice to have separate power. So now that we've wired up our Z limit, now we just need to do the X, and that will be on pin 11. So we'll take our black wire and go to pin 11. And our red wire will be on the 5 volts. These are wired up normally closed, so Mach 3 will be looking for 5 volts all the time unless the switch is made. Okay, so we have our home switches wired up, we have our stepper motors wired up, we have our tach signal wired up, we have our control wiring for our VFD wired up, we have our on and off switch wired into our motor contactor, and we have our motor spindle motor coming out of the VFD. The other thing we need to wire up is our e-stop. Now, because I'm doing this in different stages, I'll be shortly removing this 8-pin Aviation plug and replacing it with a 4-pin, because when I go to full CNC, I'll have a C6 board that'll be controlling my spindle, and I won't have a potentiometer. So there'll be a lot less switches on my control panel. So therefore, I only used an 8 conductor wire here. If you're going to be using a potentiometer and manually control your spindle and CNC, then you might want to go with a 10-pin Aviation plug, or you can do like I'm doing, and I'm just going to simply run some more 2-wire cable and then connect it straight into my e-stop and back to my control board on pin 10, and then that'll go straight to my e-stop. I have actually 2 contacts on the e-stop. One is going to go to Mach 3 through the breakout board, and then the other goes to my VFD to stop it, because I want to make sure that when I hit the e-stop, everything stops. So next we're going to wire up this. So what I did was I just pulled in a 2-wire cable, and this will be connected to pins 10 and the 5 volt beside it. So pin 10 will be my red wire, and my 5 volts will be on my black wire. think so. Got those connected. So that's my e-stop. And right now I just have it going through a hole, a screw hole that I'm not using. And that will go out to my control panel. And then once I get it hooked up to full CNC, I will disconnect it. Okay, so we finally got all our wiring completed. So now let's just do a quick recap on what we've done. In the previous video, we wired up all of our aviation plugs. And then in this video, we made all the connections inside the box. Okay, so we're about finished with the wiring of the electronics cabinet. I've got two more things I want to wire up. One is the solid state relay for my outlet that's going to go to my coolant pump. And the other is the C6 board. The C6 board I'm going to wire up later down the road. At first I'm going to have manual controls with a potentiometer, and then we're going to do away with that and go with the C6 board. But for now, I've got it wired up. I'm going to be wiring it up first with a potentiometer. So really the only thing left to wire up is our solid state relay. So we've got 4 wires we need to connect to it. We have our coil, which is 3 to 32 volts, which will be turned on and off with a output from Mach 3. I know I told you earlier not to try to stay away from these, but because this relay has these spades on them, and I may use that relay somewhere else, I just went ahead and crimped some on. Now, let's connect the wires from Mach 3 first. I'm going to be using my common from pin 9 or power. I have my board set up where 2 through 9 is my 5 volts. So I'll connect my voltage. And I'll just bring this spade over to the positive side of the coil. And it's marked on here, plus and minus. And then we just need to connect up the negative, which will be 9, pin 9. Okay, and that goes to the negative side. Now our coil for our solid state relay is hooked up, and it'll go on and off whenever Mach 3 tells it to. I went ahead and pulled the outlet out because it was just easier for me to get to these terminals. We now have a set of contacts in the back that we need to hook up, and we just need to provide power to the contacts through the contacts. So one end of this, I'm going to take one wire and connect it to my 110 volts. Right off of TB1 here. And put that on this side of the contact. That's it. And then we're going to take the other side of the contact and that's going to go to our outlet, and it goes on the gold terminal, and it's always the small prong. The hot wire always goes on the small prong. Okay, and then we just need a neutral wire for our outlet, and that always goes on the big leg or the silver screw. Tuck it under these wires here. Okay, and then I can just put my outlet back in. Alright, and then I have just a little cover to go back on the terminal boards here. And that's it. So we have our wires that turn the relay on. Here's our connections for that right here. And then we have power coming to the contact from TB1 and power going through to our outlet. And then we have our neutral side going over to the white wire on TB1. And so there you have it. Let's see if I can get a close-up. This. So that wraps up our wiring for our CNC electronics cabinet. Everything is wired up except for our C6 board, which we'll wire at a later date. And in the next video, we'll get our motor wired installed and wired up and see if we can't get the spindle to turn. And then it will be on to the mounts for the ball screws. So I appreciate you watching the videos. Please feel free to leave any questions or comments. And have a great day.